Okay, now we'll start with the properties of context-free language. So the properties of context-free language, we'll talk about the closure properties. What are closure properties? Take any two context-free languages or any one context-free language, apply the operator over it, the resultant would always be an context-free language. So context-free language are closed under union, concatenation, closure, substitution, homomorphism, inverse homomorphism, and reversal. Whereas it is not closed under intersection, difference, and complementation, which means take any two context-free language. Every time intersection won't result in an context-free language. Sometimes it might not, and therefore it is not closed. Now, for the closure property, first we'll move in for substitution. Uh, you have for every a which belongs to sigma, for every input you have a substitution of a. That is what they mean here. So for example, if I would take sigma to be sigma to be 0 and 1, substitution of 0 is a per n b per n. It's a language. And substitution of 1 is aa and bb. So what if a word is being generated as 01? How do I substitute it? I substitute it saying that S of W will be obtained by S of 0 with S of 1. So what is S of 0? S of 0 is A per n, B per n, which is concatenated with either AA or it is concatenated with BB. And that is why we have it as A1, B1 because n varies from 1 to infinity. That is what is given here. So it is A1 B1 with BB or A1 B1 with AA. If there are two A's, it is followed by two B's, ends with AA and then BB and so on. So substitution comes based on every character what you have in the alphabet, and therefore whenever you have such kind of substitutions, you will always have a similar language. So if I could write a grammar for a per n b per n, write a grammar for AABB, then when I substitute it, it again is an context free language, and that is what they mean over here. So if L is a context free language, a substitution defined on L will also be context free. And you have all these conditions where you have a substitution, and now I am supposed to construct a new set of productions. And how will the productions be? We'll add all these productions which are defined for substitution, which can be grouped together. Fine. So here it is S of 0, which is this one, and S of 1 is xxyy. So what happens for this particular thing? It is 0 S0 and 1 S1 with epsilon. This is the language which is given for n, which is 0 and 1. Context free language for S of 0 is AS0B and AB. This is given for this particular thing. And for S1, it is XX or YY. Now, how do I combine it? I combine it in this way. S belongs to S of 0 ku padala, you substitute, 0 instead of 0, you substitute S of 0. Instead of 1, you substitute S of 1 because that is how the substitution works on. So wherever I have terminal 0, I'll substitute S of 0, the variable. Wherever I have terminal 1, I have substitute S of 1, and then define what is S of 0 and what is S of 1. Now it has to be closed under union. So you take any two languages and you will have, sorry, this is L1 union L2. You will have to have a language which has to be substituted. So how do I do it? Uh, you take any context free language. If I could add a new production saying a new starting variable which produces the starting variable of the first language or the starting variable of the second language, in addition to both the productions, then we are there with union. So if I could take two languages L1 and L2 as the context free language, add a new production to it, which means a new variable which produces s1 or s2. Then you call it as a context free language. So how do we do it? I'll just take a small example to show how it works out. Now you have the first example, first language, where I take A S1, B or AP. This is in context free language. Now I have one more production which says A, we'll take it as 0, 0 S2, 1 or 0, 1. Now these are two different context free languages. Now if I to combine with an union, I'll take a new variable. We'll take it as SU. SU is obtained by the starting variable of the first production, first grammar, or the starting variable of the second grammar. So put together, all of them are context free. Now, if I have to go ahead with concatenation, then we'll see how it works out. Now, for concatenation, L1 and L2 be two different languages. You have a context free language. Now, how do I do it? Is you have to combine one after the other. Either L1 has to come as the prefix or L2 has to come as the prefix. So, just by adding a new terminal again, suppose you have S concatenation, which produces S1 and S2. What happens? S1 talks about the set of productions which are produced by language L1. S2 talks about the set of productions which are produced by language L2. You concatenate it, add a new production to it, and there we are. And therefore, any two languages which are context free on concatenation will be context free. Clean closure, you have to add the new variable at the end. So if at all you talk about okay, I'll just do it here. Suppose, for example, you have a language S produces A, and you have to talk about A closure. It is S produces A S with epsilon. Epsilon, I am noting it as E over here just for time saving purpose. So now what happens? This is always context free. Just a recursive call which goes back for the and calling the same variable. So clean closure is done. A reversal, we always know that we can reverse any production. Okay, we can reverse any production as such, and we can form a new production. If you remember, you had left linear grammar, you had right linear grammar. We reversed it and we wrote it. So we can reverse any production as such, and that will be also context free, but it might give you a different set of language. And so all these are true, whereas what is context free language or not closed under concatenation, the simple concept is this: the first one, L1, 0 per n, 1 per n, 2 per I, is context free. The reason is 0 and 1 are dependent, 2 is not dependent. In the next case, 0 is independent, 1 and 2 are dependent. But when I intersect it, okay, when I take the common strings out of L1 and L2, you will have 0 per n, 1 per n and 2 per n, because 0 is in the first one, 0 and 1 is dependent. The second one, 1 or 2 are dependent. Combining, you take all the common strings, it is number of zeros will be equal to number of ones, and equal to number of twos, which cannot be represented by n push down automata, and your intersection therefore is not context free. Now, uh, what is the complement of it? You have L1 intersection y, CFG, sorry, CFL is not closed under complementation. If I have to talk about L intersection L2, based on the De Morgan's law, you have it is L1 complement union L2 complement, the whole complement, and therefore this is If intersection is not closed, union is closed. So the only option is complement is not closed, and therefore CFL is not closed under complementation. And now, when it comes to difference, how will I define difference? It is sigma. If you take L complement, we know L complement is not closed. How will I define L complement? It is sigma closure minus L, and therefore your difference is also not closed. So these three are the things which are not closed. We have one more topic on homomorphism. Homomorphism is mainly substitution. You substitute one in terms of the other, and therefore homomorphism is also context free. What about reverse homomorphism? You do the reverse substitution, and therefore homomorphism and reverse homomorphism are closed foreign context free language.